everyone, I'm Sana Kashif Sheikh, Assistant Professor, Department of Computer Science, Abeda Inamda Senior College. Welcome back to the series of Database Management System. Today we are going to see Conceptual Design. Now what is database design? It is a collection of processes that facilitate the designing, development, implementation and maintenance of enterprise data management system. Properly designed databases are easy to maintain, improve data consistency, and are cost effective in terms of disk storage. The database designer decides how the data elements correlate and what data must be stored. That means if our data is properly designed, the data is consistent, it improves the maintenance, okay, and it is very easy to maintain the data, it is cost effective also, and it is easy to maintain, okay, and the database designer will decide that what should the data should be included and where the data should get stored. Now database design process, it has three main steps, that is requirement analysis, then database designing and then implementation. So first we see requirement analysis. In that, first is planning. That means once the requirement come from the user, the planning stage comes, correct? This stage of database design concepts are concerned with planning of entire database development life cycle. It takes into consideration the information system strategy of the organization. Next is system definition. This stage defines the scope and boundaries of the proposed database system. So once we have requirement, we are going to plan the database development life cycle, and in system definition we are going to decide the scope and boundaries of that database system. Next is database designing. So in database designing we have two models, that is one is logical model and second is physical model. Logical model is based on that means we are making the model on paper with pencil, okay, and in physical model we are actually implementing that logical model which we have made on paper. I'll read for you. Logical model: this stage is concerned with developing a database model based on requirement. The entire design is on paper without any physical implementation or specific DBMS consideration. Physical model: this stage implements the logical model of the database, taking into account the DBMS and physical implementation factor. Next, and the main topic is implementation. Implementation means what? We are going to actually store our data, we are going to actually use the data, and we are actually going to test the data. So in that, your first is data conversion and loading. This stage of relational database design is concerned with importing and converting data from the old system into the new system. So that means suppose our data is on a book, okay, we are maintaining our database on a book, or we are maintaining our data on Excel. So now we have to convert this data and we have to load this data into our new database system, okay, that is data conversion and loading. Once our data is loaded, then what we have to do, we have to check that is this database is correct. That stage is called as testing. This stage is concerned with identification of errors in the newly implemented system. It checks the database against requirement specification. So here in testing we are going to search for any error, if any error is there in my database, or is it satisfying the requirement of the user which user wants. Next topic is introduction to data models. Data models define how the logical structure of database is modeled. Data models are fundamental entities to introduce abstraction in a DBMS. Data models define how data is connected to each other and how they are processed and stored inside the system. The very first data model could be flat data models, where all the data used are to be kept on the same plane. Earlier data models were not so scientific, hence they were prone to introduce lots of duplication and update anomalies. Entity relationship model. Entity relationship model is based on the notion of real world entities and relationship among them. While formulating real-world scenario into database model, the ER model creates entity set, relationship set, general attributes and constraint. ER model is best used for the conceptual design of a database. ER model is based on entities and their attributes and relationship between the entities. For example, see here we have two entities which we are going to represent them in the rectangle. Relationship we represent in diamond and attributes we represent in oval. So your entity relationship model is nothing but the relationship between the two entities. Next is relational model. The most popular data model in DBMS is the relational model. It is more scientific model than other. This model defines a table as an n-array relationship. So here we are going to store the data in the form of rows and columns. Okay, here the rows or the first row, which is the heading, is called as attributes, and all the rows are called as tuple. Okay. Next is network model. The network database model was created to solve the shortcoming of the hierarchical database model, which we are going to see. In this type of model, a child can be linked to multiple parents, a feature that was not supported by hierarchical data model. The parent nodes are known as owner and the child nodes are members. So in network model, one child can be connected to more than one parent. Okay, so this is a hierarchical network model. Next is hierarchical model. In hierarchical model, data is organized into a tree-like structure with each record is having one parent record and many children. The main drawback of this model is that it can have only one to many relationship between nodes. Correct? So that means only one parent is allowed. Clear? One parent is allowed and many child are allowed. So that means this model just support one to many. Correct? It will not support many to many. Here you can see in diagram the root node is the parent node. It is having 3 child. Then the first level nodes again they have child, and the next level node again they have a different child. So that means one parent can have multiple child. Okay, but one child cannot have multiple parent. This is the hierarchical model, and this is the drawback of hierarchical model, that it just support one to many and one child cannot have more than one parent. But in network model this drawback has been removed. Okay, clear?